history, the idea of nanoscience was given by a physicist Richard Feynman. The ideas and concept behind nanoscience and nanotechnology was started by a physicist Richard Feynman. Feynman described a process in which scientists would be able to manipulate and control individual atoms and molecules. So he defined a process for manipulating and controlling of individual atoms and individual molecules. He said that there is a plenty of room at the bottom. Means when we reduce the particle size of materials to nano size, the properties of the material change, surface area of the material become very large by decreasing the particle size. Gravity process less important. When the particle size is decreased to nano size, then effect of gravity on the particles become less important. Surface tension and van der Waals attraction become more important when the particle size is reduced to nano size. Current research has two crucial strands. The first to investigate and utilize the properties of very small particles which are found to have very different properties from the bulk solid. The bulk solid can be converted into small nanoparticles, and these nanoparticles have different properties from the bulk solid from which they are made. So the research on nanoscience has two strains. So one of the strain is to investigate and utilize the properties of these very small particles. And chemists have role here in synthesizing these particles. So this is the first strain that chemists are developing new ideas for synthesizing these nanoparticles, investigating their properties and developing new uses of them. The nanoparticles are being synthesized by new methods. These have new properties, and they are developing the uses for these nanomaterials. It covers such topics as nanotubes. Nanomaterials may be in different form. Nanomaterials may be in particle form. They may be in tube form. They may be in coating or in thin film form. And the nanomaterial may be in alloys. Alloys can also be converted into nanomaterials, composites. Nanomaterials can be in form of components, particles for sunscreens, in the sunblock creams or sunscreen lotions. Nanoparticles are used. They are used. Nanomaterial are used as catalysts. They are used as colloids because they form colloids, and quantum dots. These are small nanoparticles to name but a few. These are different types of nanomaterial in the form of tube, coating, alloys, composites. They can be used in sunscreen as a catalyst, colloid formation, and quantum dots. The second strand for the current research of nanoscience is to be able to manipulate and manufacture things very precisely on nanometer scale. For example, the electronic circuits can be constructed in nanometer scale. So there is a research on this trend, that how nanometer scale things can be manufactured. Some techniques and processes such as photolithography for the printing of silicon chips are also called top-down process. For nanomaterial synthesis, actually there are two processes involved, top-down process and the second one is bottom-up process, which are given here. Top-down process is that process there is a bulk material. Bulk material is converted into small particles and then into small nanoparticles. And these nanoparticles can be converted into cluster, and then these are consist of individual atoms. So formation of nanoparticles from the bulk material is called top-down method. And bottom-up method, the different types of atoms, the reaction between the different types of atom can be used for the formation of cluster of atoms and then for the formation of nanoparticles. So nanoparticles, when they are formed by the atoms, by the reaction of different types of atoms, nanoparticles are formed. This type of technique of formation of nanoparticles is called bottom-up method. So there are two techniques for synthesis of nanomaterials. Some techniques are photolithography. Photolithography is the use of radiation for cutting off silicon chips. So on the bulk material, we uh, on the bulk material when ultraviolet radiation fall, this bulk material is converted into silicon chips. And this technique of synthesis of nanometric silicon chip is called top-down process because they are carving out or etching nanometer size structure, uh, because from the bulk structure nanometer structures are being made. These are clearly based in technology, although the process are often chemical. This process, chemical or chemical conversion, take place when ultraviolet radiation fall on photolithography is actually a chemical technique. The building of structure, self-assembly process and direct manipulation of atom into nanostructure is called bottom-up process. These atom, they self-assemble, form clusters. A reaction can take place between different type of atom clusters, and then nanomaterials are formed. And this type of technique of formation of nanomaterial is called bottom-up process. Here are the different definitions of nanotechnology or nanoscience. Nanoscience is the study of phenomena and manipulation of material at atomic, molecular and macromolecular scales where properties differ significantly from those at larger scales. So at atomic scale, at molecular scale, at macromolecular scales, the properties of the materials are different from the properties of the bulk material. And the study of these type of material and manipulation of these type of material at atomic, molecular and macromolecular scale is called nanoscience. And what is nanotechnology? Nanotechnology is the production and application of structures, devices like electronic devices and systems for controlling shape and size of nanometer scale. Production of nanometer materials and the application of these structure. These technologies are included in nanotechnology. Here is another definition of nanotechnology. Nanotechnology is the understanding and control of matter at a dimension of roughly 1 to 100 nanometer. When the matter have particle size 1 to 100 nanometer, then studying of this type of material, synthesis of this type of material, application of this type of material, all things are included in nanotechnology. When the particle size is from 1 nanometer to 100 nanometer, where unique phenomena enable novel application. When the materials are converted into particle size, become very small, 1 to 100 nanometer, then the material changes its properties. So its properties become very special, very unique, and these nanomaterials can be used for novel application, mean for new applications, for synthesis of new devices, new systems. Encompassing nanoscale science, engineering and technology, nanotechnology involve imaging, measuring, modeling and manipulating matter at this length scale. What is done in the nanotechnology? Nanotechnology is related with science, engineering and technology. And nanotechnology involve imaging, electron microscope imaging of the material, measuring of the different properties, modeling and manipulating matter at this length scale, making of material, and then manipulating and use of matter which have the length scale of 1 to 100 nanometer. These all things are included in nanotechnology. Consequences of nanoscale. When the material is converted into nanosize, its properties totally change. For example, here this is the gold. We normally see gold in bulk form. In the bulk form, the gold is of golden color. But when gold is converted into nanoparticle. Here the particle size is 100 nanometer. It is purple color. When the particle size is reduced to 20 nanometer, its color is 20 nanometer. So its color depend on its particle size, because different particle size scatter the light at different angles, and due to which the different particle size give different color appearance. Here is the same case. This is for copper, cadmium selenide and cadmium selenide. These are cadmium selenide nanoparticles, but they have different particle size. So different particle size of the cadmium selenide nanoparticles have different colors due to different scattering of light. This is optical property, but all other properties are changed when a bulk material is converted into nanomaterial. Small particle may melt at much lower temperature. Bulk material will have high melting point, but nanomaterials will have low melting point. Then bulk and often much harder. The nanomaterials are much harder as compared to the bulk material. 6 nanometer copper grains are 5 times as hard as bulk copper. When copper is converted into nanoparticle of the size 6 nanometer diameter, its hardness increases 5 times. Nanoparticle morphology. Nanoparticles have high surface to bulk ratio. As the particle size decreases, surface area increases. So when the material is in nano size, it has very high surface area as compared to the surface area of the bulk. Lattice energy, surface energy terms, and terms due to faults and or defects such as dislocation, as all these terms are now significant. When the material is converted into nano size, its lattice energy increases, surface energy increases, and the terms which are due to defects, these terms also become significant when the material is converted into nano size. This can lead to unusual crystal structure such as thin films of body-centered cubic copper. Copper can be converted into nanometric thin films. The film or a small layer which have thickness of 1 to 100 nanometer, that film or layer of the material is called nanofilm. So, copper can be converted into nanofilm, and in this nanofilm, the crystal structure is different from the bulk copper. Cadmium selenide, this is about bulk cadmium selenide. Bulk cadmium selenide is converted from tetrahedral structure to 6 coordinate structure when we apply the pressure of 2 gigapascal, a very high pressure, to the bulk cadmium selenide. But in case of nanometric cadmium selenide, whose particle size is 4 nanometer, it required high pressure. Bulk cadmium selenide required 2 gigapascal pressure for this conversion, and 4 nanometer particle size cadmium selenide required very high pressure 6 gigapascal for the same type of conversion. What is the reason? Reason is given here. This may be a resistance to the exposure of high index crystal planes in the newly formed nanocrystals. Newly formed nanocrystals, which are formed in 4 nanometer cadmium selenide, its high index crystal planes are exposed because surface area is increased, which would not have the normal thermodynamically stable morphology. like the bulk cadmium selenite. So morphology is not stable, surface energy is high when material is converted into nanometric size, nano size. The condition and method of synthesis alter the morphology of nanocrystal. Nanocrystal morphology is changed by conditions of synthesis and by methods of synthesis. Different methods of synthesis will synthesize different morphology of nanocrystal. Different crystal phases can catalyze specific reactions. Because the reaction also depend on the crystal phases. So especially when the nanomaterial is used as a catalyst, its different crystal phases will be specific for different reaction. Properties depend critically on the size and shape of the particle produced. Properties of the nanomaterial also depend on size of the nanomaterial and shape of the nanomaterial which is produced. So size and shape are very important, which will decide the properties of nanomaterial. These are the same images. Uh, this is first about a diamond film grown with methane, hydrogen and 0.2% pH3, showing 100 square facets. The front faces on the morphology are 100 square facets, and the second one, the different faces are on the surface. A diamond film grown at lower substrate temperature. Now the crystal are predominantly 111 triangular facet. So different faces appear when the synthesis conditions are different. So its different phases will be involved in different types of reactions. Electronic structure of nanomaterials. In nanoparticle, there are band of energy, but are different from the bulk. This is a bulk crystal, and the bands are like this. They do not have quantization. But when the particle size is decreased, these bands become quantized. As you can see the line, these lines are showing that bands are quantized. Only certain energy bands are possible. All energy values are not possible. So, um, by decreasing the particle size, the band gap also increases. This band gap is small in bulk material, and when particle size small, the band gap increases and the bands become quantized. Energy levels are quantized. Size decreases and number of orbital energy level also decreases. When the size of the particle decreases, here the on right side particle size is decreases, number of orbital energy level also decreases. Here are more orbital energy level, less orbital energy levels and least orbital energy level due to decrease in particle size, and the energy level become quantized and band gap increases. So quantization takes place and band gap become high. For semiconductor carbon nanotube, the band gap generally increases with decreasing diameter. This is carbon nanotube. Its diameter is in nanometric scale, so that is why it is called nanotube. It is a single layer of graphite, which is in the form of tube. So when diameter of this tube increases, the band gap will decrease, or when the diameter decrease, band gap will increase. But for nanotube structure, the band gap becomes zero, and the nanotube are then metallic conductors like graphite. So for certain diameter, these as the graphene sheet have free electrons. So for certain diameter, the band gap becomes zero, and the nanotubes are like metallic conductors. They can freely conduct electricity. When we have structures on a nanoscale, where level at the tops of occupied bands are not so close in energy as we have seen, then this can affect the conductance. This is the top of occupied band, the nanostructure energy level. This is the top of occupied band, and when there is high distance between the uh, other bands, high energy gap, then this can affect the conductance. Due to this large gap, the conductance can be decreased. Under certain condition, electrical conductance through a nanostructure is quantized and increased in stepwise fashion with increasing voltage. As these energy levels are quantized, so electrical conductance of nanostructure is also quantized. And how it increased? By increasing the voltage, the electrical conductance of nanomaterial increase, but not in discontinuous form or in quantized form. It increases in stepwise fashion. Electron tunnel into the structure and fill the lowest empty quantized level until all the levels below the highest filled level providing electrons are full. This figure is showing electron fill the lowest empty quantized level until all the level below the highest filled level providing the electron are filled. So in the nanostructure, the electron start filling from the lowest energy, then high energy, then high energy, and the first lowest energy levels are filled, and then high energy energy levels are filled.